Hello students, the next question is evaluate integral by reversing the order of integration. I have solved two problems here. The first problem is integration of 0 to 1. This is with respect to y. Now second integration is root y to 1. This is with respect to x. So I have written here x is equal to root y. So if I take the square root on this side, it will become x square is equal to y. This is nothing but a parabola. So in the graph I have drawn the parabola. Fine. Now here when y is equal to 0, I have taken from here. Fine. So x will become 0. So it starts from here. So here y, if I take 1, then x will become 1. So you can see here. Here I have drawn the line. We want this area. Fine. Now reversing the order. What we have reversed? Here dx, dy is there. Here I have taken dy and dx. This is called as reversing the order. Now 0 to 1. Fine. Then the next one is 0, that is here, to y is equal to x square. Fine. This one now. So integrating, if I integrate with respect to y, so this whole term will become constant and this will become y. So 0 to x square. So I am going to apply the upper limit. Fine. So this we cannot solve so easily. So there is a substitution method. T is equal to x cube plus 1. I have taken this. So if I differentiate this, this will become 3x square plus 0 because of constant. Now this 3 will come in the denominator. This dx goes on the right hand side. This whole term you can see here. So in place of this I am going to substitute t, and in place of this I am going to substitute dt by 3. Fine. Now here the limit is 0. It means if I put x equal to 0 here, then I will get t value as a 1. And here the limit is 1. So when I put x is equal to 1, then t value will become 2. 1 plus 1 will become 2. So I have written the integration range is from 1 to 2. Here square root of t dt by 3. So integration of root t is nothing but t raised to 3 by 2 divided by 3 by 2. This 2 goes up, 3 3s will become 9. In place of t, I am going to substitute the upper limit is 2. So 2 raised to 3 by 2 minus the lower limit is 1. 1 raised to anything is 1. Fine. If you calculate this in the calculator, you will get final answer as a 0.4063. I hope you understood this. Let us move on to the second one. So integration of 0 to 1. It is with respect to x. Now next one is x to 1. This is with respect to y. What I have done is, since it is respect to y, this one, I'll consider this. So I'll start with the 0, and this linear line is x is equal to y. Fine. Here it is 1. So on the y-axis I have taken y and I have drawn a line. This is y is equal to 1. So what I am going to do is I am going to reverse the order. Fine. So in place of dy I have written dx. In place of dx I have written dy. Since the range is from 0 to, you can tell y, so I have written 0 to y. I am going to integrate with respect to x here. And here 0 to 1, this is from 0 to 1 here. I hope you understood. Then next one, this part I am going to integrate with respect to x. So this will become e raised to x by y. As you know that it will become 1 by y. Fine. Here dy. So the range is 0 to y. 0 to y. In place of x, I am going to substitute y. You can see y by y cancels, e raised to 1. Then this lower limit, if I substitute e raised to 0, e raised to 0 is 1. Now I am going to integrate with respect to y. This whole term will become constant. This integration of y will become y square by 2. So the range is from 0 to 1. Here I have written 0 to 1. In place of y, I am going to write 1. Fine. So this will become 1 by 2. So I have written here 2. So e raised to 1 minus 1, you can calculate in the calculator. You will get final answer as a 0.8591. I hope you have understood this sum. Thank you.